An invisible force field surrounding Earth, strong enough to halt solar storms, yet delicate enough to be disturbed by them. It's called the inner magnetosphere, and it's doing much more than you might realize. Shielding our planet to powering dazzling auroras, this hidden region of space serves as the Earth's first line of defense. The plasmasphere is composed of low-energy particles that drift up from the ionosphere, forming like a sphere-up reservoir of very cold, fairly dense plasma that co-rotates with the Earth. The ring current is a population of medium-energy particles that drift around the Earth, with proton drifting in one direction and electrons drifting in the opposite direction. The radiation belts, also called Van Allen radiation belts, consist of high-energy particles that are trapped in two regions. These particles moved along the field lines toward the poles until they are reflected back, creating a bouncing movement. Particles with high enough velocity along the magnetic field will follow the field lines to the poles and enter the upper atmosphere. The radiation belts, ring current, and plasmasphere overlap in the Earth's inner magnetosphere. Approximate distances in Earth radii. Plasmasphere. 1.5 to 5 Earth radii. Dense, cold plasma, co-rotates with Earth, shape varies with geomagnetic activity. Ring current. 2 to 7 Earth radii. Charged ions drift westward, intensifies during geomagnetic storms. Inner radiation belt. 1.1 to 3 Earth radii. Mostly high-energy protons, relatively stable. Outer radiation belt. 3 to 7 Earth radii. Dominated by energetic electrons, highly variable with space weather. These distances change with space weather. For example, plasmasphere shrinks during geomagnetic storms, outer radiation belt expands or depletes depending on solar wind conditions. All these structures lie within the inner magnetosphere, which typically extends to about 6 to 8 Earth radii on the day side. The plasmasphere is an inner part of the magnetosphere. It is located just outside the upper ionosphere located in Earth's atmosphere extending up to about 20,000 kilometers, 3 to 4 Earth radii. It is a region of dense, cold plasma that surrounds the Earth. Although plasma is found throughout the magnetosphere, the plasmasphere usually contains the coldest plasma. It plays a role in radio wave propagation and influences the behavior of the radiation belts. The ring current stores large amounts of energy from the solar wind. Acts like a battery that charges during geomagnetic storms and discharges during storm recovery. When the ring current strengthens, for example, after solar storms, it reduces Earth's magnetic field strength on the surface. It can impact satellite electronics, communications, and GPS accuracy. Ring current. A donut-shaped current of energetic charged particles, mostly ions, some electrons, circulating around Earth. During periods when there are no geomagnetic storms affecting the area around Earth, left image, high-energy protons, with energy of hundreds of thousands of electron volts, or keV, shown here in orange, carry a substantial electrical current that encircles the planet, also known as the ring current. During periods when geomagnetic storms affect Earth, right image, new low-energy protons, with energy of tens of thousands of electron volts, or keV, shown here in magenta, enter the near-Earth region, enhancing the pre-existing ring current. The radiation belts around Earth are also called the Van Allen radiation belts. They are named after James Van Allen, the American physicist who led the team that discovered them in 1958 using instruments aboard the first U.S. satellite, Explorer 1. There are two main radiation belts, the inner and outer. The inner belt primarily consists of protons, while the outer belt mainly contains electrons. They encircle Earth, starting at about 1,000 kilometers above the surface and extending up to 60,000 kilometers. They contain trapped charged particles, electrons and protons, from the solar wind, held in place by Earth's magnetic field. They can pose a risk to satellites, astronauts, and electronics in space. Plasmasphere and radiation belts. Animation depicting how the outer boundary of the Earth's plasmasphere, the plasmapause, and the two Van Allen radiation belts vary when the geomagnetic conditions change. This is a visualization of the radiation belts with confined charged particles, blue-yellow, and plasmapause boundary, blue-green surface. Two donuts of seething radiation that surround Earth, called the Van Allen radiation belts, have been found to contain a nearly impenetrable barrier that prevents the fastest, most energetic electrons from reaching Earth.